Alright, so we have a solve problem here where we solve with a radical. Now the idea is you need to get the radical by itself, and notice our problem is we have two radicals in this equation. So one of them, the one on the right, is isolated. In other words, it's by itself on one side. The one on the left has a plus 1. Now, we could try to get the one on the left by itself and subtract 1, but we would just be moving that one that's not under a radical to the other side. So really, it's good the way it is because this one is isolated. So the next step, after you get one of the radicals isolated on one side, in other words, by itself, you square both sides of the equation. So I'm going to say the square root of x plus 2 plus 1 squared is equal to, so that's a squared, the whole thing, right, is equal to the square root of 3x plus 3, all squared. Now, why did I do that? Because what's going to happen is this square root and this square cancel each other out. Now, over here, I would love to tell you that this square root and this square cancel each other out, but they don't because this square root does not extend over this plus 1. So, fun for us, we need to multiply the left-hand side out. What do I mean by that? Well, you multiply the square root of x plus 2 plus 1 times another square root of x plus 2 plus 1. That's what the whole thing squared means. Now, on this side, this is great. That's just 3x plus 3. No square root anymore. We handled that. Over here, this is why we learned how to multiply these binomial square roots. So when I multiply, here I'm going to do this in long form. It's going to get old. This one times this one is going to be the square root of x plus 2 times x plus 2, right? Because it's the square root times the square root, which is really the same as saying the square root of x plus 2 squared. Well, we'll get to that in a minute. That's that, okay? This times this is plus 1 square root of x plus 2. Okay, when I multiply the inner, 1 times square root of x plus 2 is plus another 1 times the square root of x plus 2. And then finally, the last 1 times 1 is plus 1. Now on the right, we still have 3x plus 3. Now we need to simplify what looks like a disaster. I promise it's going to get better in just a minute. But we need to simplify this. Now again, I want you to think about what's happening right here in this first square root is that's the square root of x plus 2 squared because there's two of them. So what's going to happen is this square root and this square cancel. And listen, whenever you multiply a square root times another square root that's identical, you really just get what's underneath. So that is just x plus 2. These two guys right here, those are like terms. So I have 1 square root of x plus 2 plus a second square root of x plus 2. That's going to give me 2 of them. So I have 2 the square root of x plus 2. And then I still have that plus 1 at the end, and that's still equal to 3x plus 3 on the right. Now my goal at this point is to simplify the left as much as I possibly can. I can add together this 2 and this 1. So that's going to give me x plus, and I'm going to write this term next, 2 square root of x plus 2 plus 2 plus 1 is 3 equals 3x plus 3. Now, one thing I'm noticing right off the bat, look, there's a 3 on both sides. If I could, I could say at this point, minus 3, and those guys just cancel. That helps me a little bit. I don't have as much to deal with. What do I have to deal with? Well, let's keep going. So what am I left with? I've got x plus 2 square root of x plus 2 on the left side, and I've got 3x on the right side. Now what happens is I still have a square root in my problem, right? But it's better than having 2. We started out with 2 square roots in our problem. Now we have a single square root in our problem. What am I going to do with that single square root? I'm going to get the square root by itself. I need to isolate this guy right here on one side of the equation. What does that involve? Well, I need to subtract x from the left, and I need to subtract x from the right. Remember, whatever you do on one side, you're required to do on the other side as well. So those cancel, and now I have 2 square root of x plus 2 equals 3x minus 1x is 2x. And now I need to get rid of this 2 as well. So I'm going to divide each side of this equation by 2. Okay? Those 2's cancel, and now I have the square root of x plus 2 is equal to x. Now, I know it still looks like a train wreck, but it looks better than what it did to start with. Now, to get rid of the square root, I'm going to do what I did the first go around, is I'm going to square both sides. I'm going to square the left, and I'm going to square the right. How does that help? The square root of x plus 2 all squared. Remember, those cancel each other out, and I get x plus 2. And on the right, I have x squared. Now, what do I do with that? Well, if you'll remember, this is what we call a quadratic equation. And we talked a little bit about this in section 7.6. You need to get that equal to 0. That's our goal, is to get any quadratic. Now, what makes it quadratic is the x squared. Get that equal to 0. To do that, listen, I'm going to subtract x from both sides. First, let's do this one step at a time. So now I have 2 on the left because those cancel, and I have x squared minus x. Still got to get it equal to 0. So the next step is I'm going to subtract 2 on both sides. Okay. On the left, that gives me a 0, which I'm required to have, and I have x squared. I'm going to write the minus x and then minus 2. So now I have to solve this equation. Okay, so I'm going to go to another page to do that so we have more room. Okay, so I've added another page, and so here we are, 0 equals x squared minus x minus 2. Now, look, I wrote it the other way with x squared minus x minus 2 on the left and 0 on the right. You know, you can do that anytime you want. Now, okay, so I've got it on a new page. We're trying to solve x squared minus x minus 2 equals 0. The thing I need to do here is factor. Okay, so I'm trying to find numbers that multiply to be negative 2, add to be negative 1. We know what that is. That's going to be x minus 2 times x plus 1 equals 0. Okay, if you check it, x times x is x squared. X times 1 is plus 1x, but then negative 2 times x is minus 2x. That adds to be negative x, and negative 2 times 1, of course, is negative 2. So we're good. And then I set each factor separately equal to 0. Now that's going to result in 2 answers, because when I add 2 to both sides, I get x equals 2. And when I subtract 1 from both sides, I get x equals negative 1. Notice how quickly I circled it. But you know what? Fact is, I must check these. It's not that we did the work wrong. It's something called extraneous solutions. So I have to go back to my original problem. If you'll remember, right here, the square root of x plus 2 plus 1. And, well, on and on. I'm going to try to check in green on this same page. So remember, my 2 answers were 2 and negative 1. So first I'm going to check 2. If I take the square root of 2 plus 2 plus 1, does that equal the square root of 3 times 1 plus 3? That's the question. Real quick, the square root of 4 right here is 2 plus 1. Over here, that's the square root of 9. Are they the same? You better believe it, right? That we're good there. So that one checks out. Now I'm going to check, I don't want that color, I want purple. There we go. Now I'm going to check the other answer. Remember the other answer was negative 1? Let's check it. So square root of negative 1 plus 2 with the plus 1 on the outside, is that really equal to the square root of 3 times negative 1 plus 3? Okay, well, that's the square root of 1 plus 1, so overall on the left we have 2. On the right, I've got negative 3 right here plus 3, that's the square root of 0. You know what? That's not true. That says 2 equals 0, because the square root of 0 is 0, and that didn't work out, right? So I'm checking it again just to be sure I wrote down everything right. Yeah, so it looks like our only answer is actually the first guy, x equals 2. X equals negative 1, again, is what we call an extraneous solution. So you don't have to type that in. The only thing you type in is your 2. That was a doozy of a problem. I could see why anybody would have trouble with that. I hope you have a wonderful day. Please let me know if you have further questions.